Now we'll be solving question number 4 from previous year problems from chapter called Laws of Motion, phase 1. This is the question which came into 1994 in IIT exam. Okay. So now let's see the question. A block of mass 0.1 kg is held against a wall by applying a horizontal force of 5 newtons. So this is the wall and this is the block. We are applying a force F, which is 5 newtons. Now, if the coefficient of friction between the block and the wall is 0.5, so mu value is 0.5. The magnitude of the frictional force acting on the block is, so we have to calculate the magnitude of friction force. So whenever friction comes into the play, we should always keep in mind the friction can be static and can be kinetic as well. So in this case, this block is not moving. Since this block is not moving, the friction is static in nature. So now let's see the forces. So mg will be acting downward direction. This force 5 Newton is acting towards side, which will be balanced by the normal reaction. The normal reaction in this case will be coming horizontal to balance this force. The body will have a tendency to go down because of mg, so that will be prevented by the force. The acceleration is 0. Now, since the motion is not happening, this friction is not kinetic, and they're not talking about the critical condition. They're not asking some maximum or minimum or something like that. So this is not a critical condition and motion is not happening. So in that case, the friction has to be static in nature. And as far as the static friction is concerned, the net force is 0. Friction force will be acting such that motion should not be happening, meaning this will be sufficient to prevent the downward motion, and downward motion which is caused by mg. So since acceleration is 0, I can say friction will be equals to m into g because acceleration is 0. Now mass is given, which is 0.1 multiplied with the value of g, which is given as 9.8, and that will give us the value as 0.98 Newton. The friction force which is acting in this case is 0.98 Newton. Just for the checking purpose, if I want to calculate the Fk, because this is the friction, and this friction will be less than the Fk, it has to be less than the Fk. If I want to calculate the Fk, I need to first calculate the normal reaction. As you can check, along the horizontal net force also 0, so normal reaction will be equals to 5 Newton. And Fk, which is the maximum possible value of friction, will be mu times of n, and that is 0.5 multiplied with 5, and that gives us 2.5 Newton. So this is the maximum possible value of friction, but that much is not needed. To prevent the motion, the friction value which was required was 0.8 Newton, which is less than the Fk. So in this particular case, 0.98 Newton will be acting to prevent the motion. And as you can check the options, option B is the right option. Okay. And as you can check, basically, just to confuse, they have kept the option D as 0.49, which you will be getting from the Fk. That option is also available. Oh, sorry, option A, which is 2.5 Newton. So that option is also available. Some of the students might have assumed Fk and might have calculated from here, so they may be wrong. So because whenever friction is coming, you have to keep in mind that whether this friction is static or kinetic. Then only you can write the value. I hope you understand that.